Hello, everyone. My name's David Montgomery, data journalist with NPR News. Thanks for joining us here this afternoon for a very impromptu, unscheduled live stream. What I'm doing today is doing a little sort of live data analysis to give you a sense of how I do my job as a data journalist. I do a little bit of live coding and hopefully answer some interesting questions. Uh, if you're following along, you have questions, you can tweet at me at DH Montgomery or also tag at NPR News. And we've got some producers monitoring this, and they'll make sure that those questions get to me. I'm just double checking now to make sure that everything is going right. Looks like it is. But I appreciate you bearing with me because this is the very first time I've ever gone live like this. So all of this is very new and could go wrong in any number of ways. But hopefully it'll be a lot of fun and informative. As I said, my name is David Montgomery. I'm a data journalist with NPR News. So I do data gathering, data analysis, and data visualization. And we're going to do a little bit of all of that today. So the topic that I picked for this little analysis, very different from what I've spent most of my time on the past few years, which is COVID data. Probably what most of you know me for if you follow me. But I wanted to look at a particular topic, which is the 2018 Hennepin County Sheriff's race. That race saw the incumbent sheriff, Rich Stanek, narrowly lose re-election. Stanek was that race is officially nonpartisan, but Stanek was the Republican candidate, and it was generally well known. Stanek very narrowly lost. But what was interesting to me, what I want to delve into today, was in that exact same election, that exact same day, there was several other Republican candidates running in Hennepin County, most notably the gubernatorial candidate, Jeff Johnson. And Jeff Johnson, running on the same ballot as Stanek, with the same electorate, got blown out. And so what I want to do is look at the difference between Stanek and Johnson's performance with the same electorate in the same day, and see if we can learn anything interesting. So let's get going here. Shift over to my workspace here. So what you're looking at now is a program called RStudio, which is what I do most of my work in. I program in the language called R, which is a computer language that's focused on data analysis, statistics, data visualizations, etc., or at least optimized for those things. And I do probably 90-95% of my work in this on screens that look just like this. So a lot of what you're going to see now is me writing code, and I'll try to sort of explain what I'm doing in enough detail that you can follow along, but without so much detail that you'll get bogged down. And again, I'm going to keep pausing and looking away every now and then just to make sure that everything's working well. All right. So just to give you a quick orientation here, on this screen, we've got sort of four panels here. This panel in the upper left is where my document is that I'll be doing most of my work in. I've got a live notebook that I'll be writing code in. In the upper right, I've got my live console. I'll clear that out for you. And here's where you'll see all the code run, and I can also run code if I just want to run a quick thing. 1 + 1 = 2, etc., etc. In the lower left, there's a couple different panes. The most important is the environment, which will show any objects there. And in the lower right, there's a few things I can see. Help files. I can do some file navigation. I can see the output of some of my visuals, etc. So the first thing I do is I load a bunch of packages, which all have very specialized functions that I use a lot of. I won't go through all of these. Most of these are pretty standard packages. There's also two packages that I've written to make my work easier. One that has a visual graphics theme for NPR graphics. And this one has a function or two in progress that I found is really useful for Minnesota analysis. Things I use a lot, and I finally put it into a package so it'd be easier to access. Below that, I've got some sort of preloaded code here just to stop you from watching me hunt around my Finder, trying to track down files. I'll get to that in a second. So the first thing we need to do is get some data. And here I'm going to go to the Minnesota Secretary of State's webpage, and specifically their election results page, where they have results for elections going all the way back to 1992. Here I'm going to go to the 2016 general election, where you can see the overall results. Amy Klobuchar won a Senate race with 60.31% of the vote. Tim Walz won the gubernatorial race with 53.84%, etc. But what I'm going to do is I'm going to go down all the way to the bottom and click Complete Election Results, which gets to this little more detailed page. I'm going to go to the bottom again and click the Downloadable Text Results page. So this is where you get data in a raw, computer-readable format. So here's a sort of statewide U.S. Senate results here. You can see it's a little bit confusing, but basically this can be read by a spreadsheet app, and each semicolon separates a column. And each one of these columns here is something different. MN is the state. This is the 0102 is a office code. U.S. Senator is the office. 0301, 0401, those are candidate codes, candidate names, parties, votes, etc. And what I'm going to do is scroll all the way down here to all federal, state, and county races by precinct. So I'm going to copy that address, go back over to RStudio, and I'll show you what this looks like with some minimal processing. So I'm using this read delim function, which is read delimited files. The most common kind of delimited file you get is a comma separated or comma delimited file, which you might have seen abbreviated as CSV. I'm going to save this as results. It'll take about a couple seconds to download, and you can see this results appeared in the corner down here. It's got 352,881 rows, 16 columns. I can open this up, and you see it's sorted out those semicolons into a typical spreadsheet. It doesn't have any column headers. It read that first row of data in its column headers, and everything's just a bit of a jumble. Fortunately, I deal with this often enough that I've written a function specifically designed to read in this format of data from the Secretary of State's website, read SOS data. So I'm going to run that. Again, takes a couple seconds. When you click it open, now this is much more readable. We've got column names that have been assigned to understand what's happening. I've also, this first folder here, column here, precinct GOID, that's something that that function calculated, combining the state and county and precinct into a unique identifier that I'll be able to use for some of this analysis. All right. I'll deal with some of this stuff later, and I'll explain to you what's happening there. But the first thing we want to do, so you can see a little preview of our data down here in this little workspace, is I want to filter this to just Hennepin County races. So I'm going to filter to use a line of code here to filter to only precinct GOID codes that start with 27, which they all do for Minnesota. 27053, 053 being Hennepin County's unique ID number. So if I run that, and I didn't make any typos, we've now gone from 352,000 rows down to 42,000 rows. Hennepin County is the biggest county in the state, so almost certainly more precincts than anywhere else, but considerably reduced. And now I can filter, well, I don't know exactly what office names to filter by, so I'm just going to count office name, and here we can see all the different offices here. So I want office name that equals governor and lieutenant governor. And county sheriff. So I run that. We're down to 3,376 rows. And you'll notice here that we've got one row of data for every unique combination of race, of precinct, office, and candidate. So you scroll over, or I'll open up a bigger preview window here. The first row is precinct 270530005 for governor. For Jeff Johnson and Donna Bergstrom, the Republican candidates, and in this precinct, they got 508 votes. The next line is for that same race, same precinct, for Tim Walz and Peggy Flanagan, the DFL candidates, they got 704 votes. If you go down here, row 6, 6 and 7, you get to the county sheriff race. I'm not sure why it's abbreviating the Hutch there, but we'll just keep going. So we've now filtered down the data to just what we want, removing all those other races that we don't care about. And in fact, I don't want to have to keep doing this. So I'm just going to go back up to where I loaded this data, and I'm going to apply this to my base data set. All right. So now we've got the data we want. Now I'm going to start out with a sort of real top-level analysis. I'm going to check, by the way, to see if I've got any questions coming in over Twitter. Doesn't look like it. All right. So first, I'm just going to make a graph showing the results of this race here. The first thing that I need to do here is we've got over here the percent of the vote that each candidate got. And we can just actually work with that. Well, here, I'll just show you. Oftentimes, rather than working with the raw percent of the vote, I like to work with what's called the two-party vote. That is to say, of the candidates who voted for the two major parties, what percentage of the vote went to each candidate. Sort of setting aside third-party candidates. There are some races where third-party candidates are important and can't really be discarded like that. But a lot of times, what you really want to know is, of the two candidates who had a serious chance of winning, how do they do relative to each other? Because if someone gets 49% of the overall vote, but they have a 3 percentage point lead over the other nearest candidate, what really matters might be that they got 53% of the two-party vote. So first, what I'm going to do is I'm going to filter again to just party in where the party is equal to R or DFL. Oops, but that mistake here. You might notice this is all governor, lieutenant governor. That's because the sheriff's race is nonpartisan. So I'm going to quickly fix that here, because while it is officially nonpartisan, in practice, Rich Janik was a Republican, and his rival was a Democrat. And pretty much most people knew that. So I'm just going to automatically put that in here. So I'm going to write a conditional statement when the office name equals county sheriff. Actually, no, you can do this even better. Candidate equals Dave Hutch. Again, not sure why. If you look at these results here, this data is making me second guess myself. The Hennepin County Sheriff's named David Hutchinson. I'm not sure why it's listing him as Dave Hutch. In any case, not important. It's listed as Dave Hutch here, so for the purposes of analysis, it's Dave Hutch. So I'm going to set when the candidate equals Dave Hutch to DFL, when the candidate equals Rich Stanek to R, otherwise to stay the same. So now we've got the parties in there. So now we can filter to just include Democrats and Republicans. Now I'm going to group by each precinct and office name. I'm going to create a new column called %2party. And that's going to be equal to votes divided by the sum of the votes. So here, we're going to do, I'll blow this up a little bit. For each precinct and for each office name. So in this first precinct, 270530005, we got these two rows for governor, Johnson and Walz. We're going to create a new column that for each one of those takes that column's value divided by the sum of those two values. So now we can see that in this first precinct, Johnson got 40.48% of the total vote. He got 41.9% of the two-party vote because a small part of the vote went to third-party candidates. Walz won 56% of the overall vote, 58% of the two-party vote. This analysis would work with overall percent or two-party percent. It doesn't really matter. I often like working with the two-party share. All right. So now, look what we've got here. In fact, actually, I don't want to do that yet. A lot of my analysis, I'm jumping around and realizing I should have done things earlier. Instead, I'm going to group by office name and candidate. And I'm going to summarize. There we go. So now, here we have, in Hennepin County precincts, the total number of votes won by each candidate. Much simpler than this massive thing. You notice also that it dropped the columns that weren't involved in this analysis, which is fine because I was scrolling back and forth already. So now I can group by the office and do that same calculation. I'm just going to call this percent, drop the two-party label. So now we've got the data. I'm going to do one final thing. Oops. Actually, go and make sure include party in here too. Oops. There we go. So now we've got the party listed. Now I'm going to filter to just the Republicans. You'll see why in a moment. And now I'm going to make a graph. Use a graphing library called ggplot, which is very powerful and surprisingly easy to use. Not actually easy, but easier than you'd think. So I'm going to define my variables. My x variable is going to be the candidate. The y variable is going to be the percent. And I'm going to make it a column graph. So now, you can see a quick and dirty graph. I often like to make my bar graphs horizontal, so I'm going to flip that. One thing that jumps out here, the last listing lieutenant governor makes this look a little ugly and weird. So I'm going to go back and drop that. And use that function to just select the first two words of candidate, dropping the lieutenant governor from there. Now that's much better. There's still a lot I can do to polish this. I'm going to add some direct labels here onto the axis. Those are small. You can't quite see them. So let's make that bigger. Going to adjust the justification to not to be inside the bars rather than overlapping the ends. make them bigger, and white. There we go. I mentioned that I had written a custom visual theme. Here, if I add this plus theme NPR line, it's going to instantly apply that. And now the whole appearance has changed, and it's much more in line with the graphics you're probably used to seeing from NPR. Because I've directly labeled the bars here, I don't actually need an axis. So I'm going to remove my axis titles, set those to element blank. I'm going to remove the x-axis text as well. And we're almost done here. I'm just going to add some labels, a title. 2018 two-party vote share in Hennepin County. And a caption. Source, Minnesota Secretary of State. And a credit. The final bit of the magic here is another custom function I wrote. It's called add logo, which takes a chart and does a little magic to it. In particular, you might have noticed it changed some of the justifications. It added the logo in the lower right and generally move some things around. It also outputted it in a fixed aspect ratio. Rather than having to custom specify how big I want each graphic to be, it sort of fixes that. But I'm actually going to change that aspect ratio because this is a very simple graph. Now it's shorter and much better. So here we've got the quick output. You can see that Rich Stanek did almost 20 percentage points better in Hennepin County than Jeff Johnson did. Despite the same electorate, two candidates of the same party, the only one was listed. And if I do a little math here, you can see that that's 80,000 extra votes that Rich Stanek got in 2018. All right. Just checking for any comments or questions here. Doesn't look like anything. Again, if you have any comments or questions, you can tag me on Twitter at DH Montgomery. If you also tag at NPR News, one of our producers is watching and will help flag anything to make sure that I see them. So that's the basic approach. Now we're going to get a little bit more involved, and we're going to look at where Stanek outperformed Johnson. Was he better everywhere? Was he better in certain parts of the county? Etc. So we're going to start with our same basic results, which have already been filtered to just Hennepin County and these two races that we care about. We're going to keep some of this stuff we did before. Filtering, assigning party labels, filtering to Democrats and Republicans. This is the great thing about working in code. You can just always go back and copy and paste and something you did before and apply it again. It took a little bit for me to learn, but once I sort of mastered it, it made my work much faster. All right, so now we're gonna group by the precinct and the office, and we're going to calculate our two-party percent again. Oops, what did I typo? Precinct GeoID, not precinct ID. This happens a lot. A lot of mistakes, a lot of pausing my code, going back, trying to figure out what I did wrong. Usually it's something very simple, like a typo. Occasionally it's much more complex. All right. So we can then filter down to party being just Republicans again. We're going to also get rid of Donna Bergstrom. who ran a Valorant part of the Jeff Johnson campaign, but is not needed for this analysis. Cropping that down. All right, so now we've got a spreadsheet with one row for each Republican candidate in each precinct. So precinct 2705305, we've got one line for Johnson's performance and one line for Stanek's performance. What I want to do is get these side by side. I want to reshape this spreadsheet to put these in different columns rather than the same column. This spreadsheet is in what is called a long format or tall format, and I want it to get into a wide format. And you'll see the difference here in a moment. So I'm using a function called pivot wider. I'm saying that I want the names for my new columns to come from the candidate field. I want the values to come from the percent field. And I also want, as a unique ID column, I want to keep the precinct GeoID. So now, if you can compare the before and after, we've gone from this big, long, tall spreadsheet with 2 rows for each precinct to now 1 row for each precinct and a column for each candidate. In fact, I'm going to get this down to just last name and lowercase them as well, because that's just easier to work with computers. Spaces in column names are very messy, and they're best to avoid. Capitals can also get in the way. So now I'm going to make a new column measuring the difference. And basically, this is going to be Stanek minus Johnson. So we can see, in this first precinct, our good friend 2705305, Stanek outperformed Johnson by 14 percentage points. In 27053000015, he beat him by 26 percentage points. And let's sort this. Make this bigger. So right away, we have an answer to our first question. Where did Stanek do better than Johnson? The answer is everywhere. In literally every precinct in Hennepin County, Stanek got a larger percentage of the vote than Johnson did. That includes the heavily Democratic precincts, where where Johnson was in single digits and Stanek was in double digits. That also includes the heavily Republican precincts, where Stanek was getting more than 70% of the vote, compared to Johnson in the 60s. So that's interesting. What we're going to do now, we're going to map this. And I'm going to go back up to these things I skipped over earlier. One of the things I loaded in was a map of Hennepin County precincts, which I have sitting on my hard drive here. I have a statewide map of precincts. I filtered down to just Hennepin County. So what I'm going to do now is create another ggplot graph here. Got a question coming in. I'll get to that in a second here, rather than interrupting my stream of thought. So I'm going to say that I want this map to be the SF type, which stands for simple features, but basically means this is a map. That didn't work. What did I do wrong? Right, of course. I didn't actually join in my data. Big problem. All right. I knew I'd forgotten something. So let's take a look at this precinct map file. Most of this is unimportant. This column VTDID is the same thing as my GeoID that I used. So I'm going to start join in this precinct map file. I'm just going to select the column I need. Actually, if I recall correctly, I need to do this first. The order here matters for reasons that probably aren't worth getting into. So here's a simplified version. I've selected just the ID field, the precinct name, because that could be helpful, and this column for the geometry. You might have noticed that I've renamed that VTD column to match the name in my other data set. Now, if I join them, we've got the precinct GID, the name of the precinct, the geometry, and then the stuff that I calculated earlier. Let's redo the alignment here. So we can answer one question that we had earlier. The precinct where the difference between Stanek and Johnson was the smallest was in the first precinct in Corcoran. There are a couple of precincts where you don't have data. The one that's the biggest was in Brooklyn Park. All right, so now this should work. All right, so here we've got a map of Hennepin County. It's a familiar shape. I'm not sure how you describe that. It's not super informative. One thing, there's really thick precinct lines everywhere. So let's get rid of those. Shrink the size and change those from gray to white. A little bit better. I can shrink those even more. All right. I'm going to also add a custom gradient here. We've got some predetermined NPR color schemes. Nope, that's not actually what I want. I don't want a two-color gradient here. So what I'm going to do, there's a lot of experimenting in this. Trying out some different things. All right. So here we go. We've got the darker colors are where Stanek outperformed Johnson by more. The lighter colors where he outperformed him by less. One thing that's pretty obvious, one of the places where Stanek's edge over Johnson was the smallest is in the relatively rural, exurban, far-flung western part of the county. All these big precincts over here are noticeably lighter in hue than the ring of suburban counties in there. See if this works. Yep, just updated that label to be pretty percents instead of 0.1, 0.2, 0.3. Can improve this a little more. Add the theme NPR on here. Don't need the latitude and longitude, so I'll hide those. I'm going to put this label on the back on the side where it was. All right. So yeah, this is interesting. It can be a little bit of a jumble. So what I'm going to do is I'm going to go back up to the top here. Another one of these things I loaded in, which is a map of the cities in Hennepin County. I'll just show that to you right now. So here, these are the city boundaries in Hennepin County. You can see Minneapolis over there, Bloomington, all the others. What I'm going to do is I'm going to add another layer here. I'm going to specify that this comes from a different data set. I want this to come from the city map file. I want no fill. There we go. Those are a little blending in. So let's say color equals white. Little too thick for my tastes. shrink that size even more. All right. So there we go. You've got the boundaries. So now you can start to see a little bit more. So I believe that Richfield down there, as you can see, that's noticeably darker than some of the areas around it. North Minneapolis is another place where Stanek outperformed Johnson. Let's see. What else? Just one or two things more, and then I'll wrap this up. This is going for a while. We have a question coming in from Jeff on Twitter, who asked, do I have a link to the files I used? The primary file is the election results data, which is from the Secretary of State's election results page. Just to navigate through that again for anyone who joined late. The Secretary of State's election results page, I found the 2018 election, general election, complete results, scroll down, downloadable text results, and I worked off the all federal, state, and county races by precinct. That's the data I'm working with here. The map files that I'm working with, you can download a map of Hennepin County precincts from the Secretary of State's website, I believe, or possibly from the legislature. I downloaded this ages ago. In general, if you want to find GIS files, the thing to search for is the thing you want a map of, and the word shapefile, all one word. Shapefile is a common GIS format. You could also add GIS to the shapefile. And there are government bodies as well as researchers and other places have posted all sorts of GIS data files on the internet. You can access them in with free apps like QGIS, as well as R and other things. And Jeff also asked why I chose R. The answer is sort of by mistake or accident. When I was just getting started, I was looking for a shortcut for a really repetitive project. I Googled if there was some sort of code thing that could automate what I wanted to do for me, and the result I found was R, and that sort of kicked me off down this road. But in general, R is one of three really commonly used languages for data journalists. The other is Python, which does a lot of the same things as R, a little bit less specialized in stats and visualizations, which has some pluses and minuses. And the other is JavaScript, which is used for interactives online. All right. So we'll add a little bit of final polish to this graphic here. See if this might be too long to fit as a headline. I often start out with really long headlines and then trim them down to something that will fit. Add in those labels. Yep. Unfortunately, with maps, the alignment can sometimes get wonky. With weird white space, it's some bugs that I just haven't managed to sort out. It's unfortunate. But I'm going to have to jump that down to a second line. Sometimes I just have to manually crop these. And let's add a label instead of just diff. Let's say Stanek overperformance. I'm going to try actually something, see if this works. No, that will not work. Okay. Yeah. So that's step 2. There's one other thing I want to look at here. I wouldn't ordinarily do this live, but as it happens, I did most of the hard work for this for an earlier project. I have this file where I've calculated some demographics for Minnesota's voting precincts. So for each precinct, we've got the population density, the household density, the percent that's under 18, the percent population of voting age, population over 65, population of various racial groups, percent who own their home. Some of these, like percent with a college education, I had to estimate because that data doesn't exist down to the level that I needed it in. Here I just sort of had to assume that neighborhoods were similar to other nearby neighborhoods. Pretty quick and dirty. In any case, this I've already filtered down to just Hennepin County. So what I'm going to do is I'm going to, again, join these in. Join in my results with my demographics. What did I do wrong here? Okay. The GeoID in one of these is a character format, and another is a number format, which is annoying. So let's convert that back to character. These little annoyances are things I deal with all the time. There we go. Okay. Let's blow this up. So now, in addition to our voting results, we've also got all this demographic data joined in. And in fact, I don't need that I don't need the full results here. I just need, let's see. Oops. Let's filter this down. All right. So I need my already processed results here. So now I can do some simple, quick, and dirty data visualizations to see how if there are any demographic variables that explain this. So let's create a new scatter plot here. The x-axis is going to be the diff variable, this how much Stanek overperformed Johnson, and the y variable, let's say percent white. Add a little trend line in here. This is what's called exploratory analysis. I'm not focused on things looking pretty. I'm just looking for patterns. And if I find any patterns, then I expand them and polish it up and all that. So actually, we want to flip these. Generally speaking, you put the predicting variable on the x-axis and the responding variable on the y-axis. So here we can see race doesn't make much of a difference until you get to the precincts that are most heavily white. And in these, Stanek tended to have a smaller edge over Johnson. Primarily, almost all the precincts, basically except for one or two, where Stanek beat Johnson by less than 10 percentage points, were in this sort of these 90% white precincts. We noticed that above that when he made the map, that those precincts were in the far western Hennepin County primarily. So that explains that. We can check out a few other things, then I'll take any more questions and wrap this up, because this has been going on for a while now. Let's see. My college education was sort of a rough. Well, here let's look Donald Trump's 2016 voting performance. We'll use that as a comparison. How did I name this column? Pres 16. So here, this is an interesting shape. On the x-axis, we've got Donald Trump's 2016 performance in each precinct. The y-axis, Stanek's overperforming. And we can see that Stanek overperformed Johnson most in the precincts where Trump got about 30% of the vote. Hennepin County, obviously, Donald Trump lost it by a huge amount in 2016. So in those precincts where he lost, solidly was where Stanek overperformed the most. In the precincts where Trump got completely blown out, where Trump got 10% of the vote or less, Stanek had a smaller lead there, and in the ones where Trump won by a lot, Stanek had a smaller lead. The latter, this right side, makes some sense that these are the places where there's lots and lots of traditional Republicans who are probably voting Republican down the line, and you would expect there to be a smaller gap there. The left side is interesting, but we won't get deeper into that today. We'll just do one more little comparison here. Percent with a college education. This is an estimate, not an actual measured variable. I mean, all these are survey estimates, but this is even more shaky than others. Not a huge impact here. Some of the least educated, the precincts with the lowest number of college degrees in their area had a bigger lead for Stanek, but hard to say. If I were doing a detailed analysis about this, I would try some regression analysis to try to look for variables that are correlated with each other and see what control for that and see what effects there were. But yeah, this has been an experiment that apparently successful. Last chance, if anyone's got any questions, tweet them at me at DH Montgomery and tag at NPR News. Otherwise, I will wrap this up shortly. Since this seemed to work, I think we'll plan on doing more of these in the future. We'll talk with my editors about scheduling and things like that. But this seems to have been relatively successful. I'll wait another minute to see if anyone's got any questions. Anyone who's curious, it looks like there's more than 1,000 of you out there. So welcome to all of you. Glad I didn't manage to put my foot in my mouth for this complete, total experiment. Just checking over on my Twitter mentions. Even let you see that. Mostly just some likes and shares. All right. Well, I think I'm going to wrap this up. Thank you, everyone, for joining. And stay tuned for future live streams.